Cool. Welcome to this Kappa new contributors session, where we're going to actually walk through the repo structure and then walk through a actual change. So we'll have a look at a change and some of the steps that I would go through to do that. I'm not saying they're completely right, but at least it'd be practical in that respect. So I guess it would be, since we're like a small group, it would be good if you have any questions along the way, just interject. Cool. Sadef?
Yeah, I can get started.
Cool.
Yeah, I will. We will start with a walkthrough in the repository layout. Then I will show how to start a development environment using Tilt. I will try to keep it short because the fun part is the second part where we do an actual change and run the make targets to actually create the CRDs after that. So let me share my screen. Oh, host needs to give permission. I actually tried it before.
Cool, you should be good to go now.
Okay. Yeah. You can see it, right?
Yeah, can do.
Yep. Yeah, so in our previous session, Richard mentioned that we have two different kind of cluster support in Kappa. One is EKS managed, where EKS manages the control plane, and the other one is Kappa managed, where cluster API manages the control plane, lifecycle management. So when I walk through the repository, I will try to mention which folders are used for what purposes, to make things clear. And there will be some overlap with the cluster API walkthrough in terms of like repository layout, because basically we are using kube builder scaffolding too, and things are pretty much common. Like we have the API folder, we have config, we have controllers. They're all created by kube builder scaffolding. So let's get started with the API. So we have three APIs. We have two older versions, and we do support upgrade from V1 Alpha 3 to V1 Beta 1 and V1 Alpha 4 to V1 Beta 1. And we follow the end of life dates published in cluster API for these versions. For example, V1 Alpha 3 is it is deprecated, and soon V1 Alpha 4 is also going to be deprecated. So if we go into this V1 Beta 1 folder, we see a bunch of generated, let me do like this. So we have the types, basically. We have the webhooks, we have the conversion data, we have the deep copy. So these are the generated files, and mainly here the main types are AWS cluster, AWS machine, and AWS machine template. AWS cluster is not used by EKS based clusters because they have their own AWS managed control plane resource to reconcile the control plane. So this is only for Kappa managed clusters. And other things to note here, we have all the identity types here, AWS identity types. These identities are for multi-tenant support. We have controller identity, role-based identity, static identity, and these identities are shared with both EKS clusters and Kappa managed clusters, basically. And this is not the only API folder we have in the repository. We have a bunch of kube builders, nested kube builders in the project. But since we have only a single Kappa manager, we do not have the config file in those. For example, let me move to, for example, Bootstrap. is one of them. This is the EKS Bootstrap provider, and then control plane has its own set of APIs. And then the third place is experimental. We have all the experimental resources here. As of now, we support a bunch of experimental features like AWS Machine Pool, AWS Managed Machine Pool, Fargate profiles. These are the main ones. And you see, we have the same director structure. We have the API, we have the controllers, but we are missing the config directory, because we are actually having those in the same Kappa manager, basically. I'm going to show what is in the config directory in a while, in a short while. So let's move to the Bootstrap. So feel free to stop me anytime. We are a small group, as Richard mentioned. So if you have any questions. So this Bootstrap provider is for EKS. So this generates the user data for the worker machines. Basically, it creates the cloud init config. It saves it as a secret, and then it will be passed as user data during the instance creation. And this depends on EKS Bootstrap script, and that script exists in all EKS I'm not sure if we are calling them optimized, but EKS published AMIs. But if you want to use a custom AMI, you can do that by simply placing the Bootstrap script provided by EKS in the correct location, and cloud init data will work. We are just running the Bootstrap script and passing bunch of parameters with this Bootstrap provider, basically. If we move to the control plane. So as I mentioned, Bootstrap and control plane packages are specific to EKS only. This control plane is again a kube builder scaffolding. It has API and controllers, and basically it has the AWS Managed Control Plane resource. So this is where we create the EKS control plane logic. So for EKS cluster, we are also auto-creating its networking infrastructure. We concile a network with VPCs, subnets, net gateways, internet gateways, security group. Everything is same with the Kappa managed clusters there, except creating load balancers. We do not require creating load balancers because we are not managing the control plane in the EKS clusters. So that's the only part we are skipping in the infrastructure creation. Let's move on to the config directory. And this folder has all the information for the manifest creation of the components YAML, basically. So we use customize to generate the infrastructure component YAML that we publish with the releases. And that has all the RBACs, CRDs, deployment information, anything we need to basically deploy the Kappa controllers. And this sort manager is static. It is created by the kube builder. This CRD has all the CRDs generated from API types. It is using the kube builder's marks in the API folder and generates all. So here you see all the types that we have in this repository. As I mentioned before, since we are installing using a single binary and running all controllers in it, we don't have to separate this folder. And we have all the necessary RBACs here for giving the necessary permits to reach the newly created resources. And yeah, these RBACs are again generated based on the QBuilder marks on the controllers files. And when we move to the webhooks, these are the webhooks, and these are also generated by the QBuilder marks in the webhooks in API folder.
So Dev, is it possible to just have a look at the back in the config, like the manager declaration? So this is just a point here. This is if we're developing any experimental features, this is where we expose like the feature flags, and this is where the env substitutions come in, where you can set the default. So if you ever develop an experimental feature, this is where you need to change the config. Sorry, Steph.
Yeah, thanks, Richard. And yeah, this is all in the config folder. Let's move to the controllers. This is where our main controllers for the types in the API folder, basically AWS cluster and AWS machine. We do not have a controller for AWS machine template because that is passed to either machine deployment or kubeadm control plane. And AWS machine is created by cluster API logic. So we do not have to reconcile AWS machine template. It's just the template that AWS machines are created from. And yeah, we are not gonna go over the details of what these controllers are doing. Probably we will need a deep dive for it. And yeah, let's move on to the package. So this is the most important folder in the repo probably. This is where all the code we have for interacting AWS SDK. And we are using services and scopes for our interaction with the SDK. So scopes are here. Scopes are nothing but interfaces with a bunch of methods related to cluster Kubernetes objects. And we only expose the necessary methods to AWS SDK calls. So if you check here, I think I should probably talk about what cluster scoper is. If we go to the interface, we have an interface, cluster scoper interface. So this is implemented by both AWS cluster object and AWS managed control plane object. These are the common set of methods exposed by both EKS clusters and Kappa managed clusters, basically. And for the services that we share, we are using this scope. We are passing this scope so that we can share the services between those two logics. And if we go to the services, so, and probably maybe the ELB. Oh, sorry, not the ELB. Yeah, you see that in a service definition, we have all the clients that we need to communicate with the AWS SDK. So, for example, for ELB, we need EC2 instance, EC2 client as well to attach the EC2 instances to load balancers, and ELB client for actually going and creating the load balancers. And then we are passing a scope object, which will have all the necessary, which will expose all necessary methods for during the interaction of these scopes, during the interaction with AWS SDK, basically. Yeah, so other than that, there is, we have a throttle logic. So this is like a leaky bucket. We copied it from somewhere. Nadir modified it back then. So basically, we are passing those methods as handlers. If we, I mean, it is basically to slow down the AWS SDK calls to avoid hitting SDK call API limits. But this is not this is not solving all of our problems, because it is not like handling the global number of API calls. So we still need to figure out a way to maybe reduce our API calls or find a better way, because we are still seeing hitting API limits errors from time to time.
So this is region scope, the rate limiting?
Sorry?
So you mentioned this isn't global scope. This is region scoped?
No, I meant between different reconciliations. So we are
okay.
So within the project itself, I meant.
Okay, thank you.
Yeah. So yeah, this is all I want to mention in the package folder. Is there anything else I missed? Richard, do you want to?
No, we'll cover some of those in the walkthrough in a bit.
Yeah. Okay, and let me see what else we have. Yeah, we have the docs where our book is located, and we have the proposals under this one. Oh yeah, let me mention a little bit about our CLI tool. This is the utility tool where we have a bunch of helper methods. The most important one being is to create CloudFormation stack with the necessary IAM roles to run Kappa controllers. And other than that, we have options to list AMIs, encrypt the AWS credentials, etc. Bunch of helpers here. And these most of them are actually exposed as a library. So this is probably the only place that is designed with the intention of being imported by external projects. So this is the only library that you can use safely, because the rest are mostly for internal use. Other than that, we have the hack folder where we have scripts for verifying and bunch of miscellaneous checks. These are mostly used in the make files. And if you check the scripts, these are where our CI scripts are. So these are the scripts we are using for our in our pro jobs for end-to-end tests. And other than that, yeah, in this feature folder, we have a list of all the experimental features we have, and we have the information at which stage they are at. So if we are missing something in our book, this is the place to check what features we are supporting. And let me move to the test folder. So we have two folders here. The first one is self-explanatory for end-to-end, and the second one is creating the end-test environment for the unit tests by installing necessary CRDs and webhooks. This is used for most of the unit tests in the code base. And if we go in the end-to-end folder, we have the data folder where we have all the manifest templates that we use for our tests. For EKS templates, they are under this EKS folder, and Kappa managed tests are using this infrastructure AWS folder for their templates. And then we have two different configs, one for EKS clusters and one for regular Kappa managed clusters. And under this shared folder, we have all the logic that is common between the two types of tests, EKS and Kappa managed cluster tests. And in the suites, you see three different folders. Managed is, so first let me clarify. Managed is EKS managed clusters, unmanaged is Kappa managed clusters, where we manage the control plane. So sometimes there are confusions, difficulty understanding which is what. And this is where we have all the tests for the Kappa managed clusters. And we are actually calling lots of test specifications exposed by core cluster API. And our own tests, Kappa specific tests, are located in the unmanaged function on test. And for the EKS test, we have only two tests as of now. One is upgrade, and one is standard template with like bunch of add-ons. Yeah, so this is pretty much it. I'm not gonna go over the make file because probably Richard will go some of the important ones during his demo. But yeah, I can show you how to bring up the like tilt dev setup. I mean, if you wanna do it, Richard, you can, or I can do it. But I can do it.
Yes, up to you.
Cool. So first we need to create the cloud formation before we start anything. So I am exporting the AWS. So for that, I need the AWS region information. I need AWS credentials. I already have them located in my own machine, and yeah, so I have the credentials now as environment variables. I'm not showing those, and so for tilt setup, we need this B64 encoded credentials. We have a newer version of this comment, but I'm not gonna show it because it prints out the AWS credentials at the end. So yeah, I'm just using the old one right now. So, and after these steps, I'm just running create cloud formation. So yeah, so cluster AWS ADM Bootstrap IAM create cloud formation stack. We can pass config files. It's pretty flexible where we can add extra policy statements. So you see, we have a bunch of options for EKS specific IAMs. If you wanna have a separate user created for bringing up the Bootstrap cluster, you can do that also. And after we run this, okay, it creates a bunch of roles with policies attached to them. So yeah, for EKS, it requires some different permissions. So we have different roles for those and policies. I'm not gonna go into detail about this. And the next step is creating the kind cluster. While my kind cluster is getting created, let me go over the tilt settings. Currently, see that I am in the cluster API directory, and the tilt should be started here because tilt file is here. And let me show you the some fields you need to set. So in terms of providers, we want to install AWS provider. Core cluster API is automatically installed. We also want to install the kubeadm Bootstrap and kubeadm control plane provider for Kappa managed clusters because we are using those. And so this is the location of my Kappa code in my local. And so this will allow debugging of the controllers when we run it started with tilt. Also, you can enable the features using this customized substitution field. So, okay, cool. Right now, my kind cluster is up. Now I'm gonna run tilt up. So it takes a minute. So yeah, any questions so far? We are gonna have like 1 minute or so wait time. Cool. Yeah, so one thing I wanted to show before handing it over to Richard is Kappa controller will not come up because I added this debug. So it is waiting the signal that will come from this port. And how I set it up, so now I am switching to cluster API provider AWS code. And so I'm using IntelliJ, and I am creating a go remote configuration and setting the port to the ports that I provided in the tilt settings. Right now I have, this is 3000. And after all the controllers are up, I'm gonna start it in debug mode. Yeah, let me do it right away to avoid waiting. Yeah, so this is pretty much it. So all the controls will come up and you can interact with your Bootstrap cluster on your local. Pods are getting created. And yeah, so you can also use this cluster, kind cluster for running end-to-end tests locally. You don't need to create new ones for running. Yeah, that's all. I'm gonna stop sharing.
Cool. Thanks, Steph. I will share as well. Okay, so I thought I would take us through doing an actual change. So there will be some steps we might have to just miss out and revisit at a later date. But I thought we'd go through right from the beginning. So I created this issue yesterday, essentially to expose the node group update configuration via the AWS managed machine pool. I thought this would be a good issue as it touches an API change, but the actual reconciliation change behind it is not too much. So for me, the first thing I would do if I was working on this issue is just from a prowl point of view is I would actually assign the issue to myself. So using the / commands in prowl, and I would also mark it as active from a lifecycle point of view. So this indicates that I'm actually actively working on this. So I add those as comments on the issue. Prowl will then see those and assign the issue to me and add a label to say it's active. Cool. So while it's doing that, so you'll also probably see some changes on the left-hand side. So what this change is around is we have this AWS managed machine pool. So just as a reminder from, oh, don't like my spelling, from the session before. So in Kappa, we have two versions of machine pools. So a machine pool is a set of worker nodes that can scale up and down. And the idea being that the machine pool implementation that we do in Kappa or any other provider can map and take advantage of any auto scaling type feature in the cloud provider. So for us, that's auto scale groups, stroke EKS node groups. But for CapZ, that might be virtual machine scale sets. So for this change, we're interested in the AWS managed machine pool, which I still can't spell correctly. So AWS managed machine pool maps to an EKS node group, just to be explicit. And this is where obviously Amazon manage the instances and the auto scale group behind it. So you don't have to worry about those individual parts. So essentially, we don't expose this node group update config currently in AWS managed machine pool. So if I look at the EKS docs for the SDK, where we can see this. So essentially, this allows us to control how many machines are available or unavailable when it's doing an update. So we can say, well, actually, we don't want more than one machine to be unavailable, or 10% of the machines. So we want to basically expose this configuration option via AWS managed machine pool. So what I'm going to do is bring over the code window. So I will just, so as Sadef mentioned, so this is going to require an API change. So Sadef sort of talked through some of the high level folders. So machine pools is a experimental feature in CAPI, upstream CAPI that is. Therefore, it's an experimental feature for us as well in Kappa. So this is, the changes for this are going to be predominantly under the experimental folder. And this follows the QBuilder, as Sadef said. So we have the API types, and then we have the controllers within there. So I have done some pre-work on this, I guess. So if I look into the V1 Beta 1, which is our most recent API version for the experimental folder, I can see that we have the AWS managed machine pool _ types. So that we follow QBuilder conventions here. So the first part of that file name is the resource kind name. So in our case, AWS managed machine pool, and then _ types for the to indicate this is the actual public API type definition. And if I look into here, we will see usual QBuilder stuff. So we have a list type that has a list of AWS managed machine pools, and then we have the actual managed machine pool here, and that follows the convention of spec and status. So there are structs for those as well within this file. So for this change, where we want to add expose this update configuration, we need to put that into the spec of this API type. So if I go to there, so you can see within the spec, there's a whole bunch of fields, and most of these sort of relate one-to-one with AWS type on the SDK, but not always. Sometimes we wrap it or have a different UX on that. So so I am going to actually, before I do that, so these are the top level types, and any other types that are not I guess directly exposed via QBuild, but they're used by the QBuilder types, let's say, they go into a types.go. So these are structs that are used by the top level structs. So I'm going to, first of all, I'm going to create in here the equivalent of where are we? So the equivalent of this structure, basically. So we, and I should say at this point, so in Kappa, we deliberately don't expose the AWS SDK types within our CRDs. So what you'll see a lot of time is, we re-implement them, and that's just so that we're not tightly coupled to the actual SDK. So if it changes over time, we have that layer and that separation, so that we don't have to change our API types and they don't break if the SDK breaks. So I'm going to implement that. So I have done a bit of pre-work here. So right, I'm just going to right at the bottom. Sorry about this. I'm going to create a new struct called update config. So this is usual CRD type stuff. So a couple of things to note here are I'm exposing the two fields. They are optional. So I've put them as a pointer type. There's a discussion going on about how we represent these, whether we don't use pointers, if the default value has a meaning. But for this demonstration, I'm going to use them as a pointer to an integer. So we have to make sure that we do the JSON tags, so that it's so we can serialize it, and because these are optional, make sure that we put the emit empty in there as well. So the next part up is you'll see that these special comments. Now these are cube builder annotation comments. They're special, so that when we run the code generation tools and code generation tools will generate that config folder that we saw earlier. So it will create the CRD definitions, etc. This will influence what is put into that CRD definition, and specifically here, it's going to be the Open API validation on our CRD. If we look at the description of this in AWS, we can see the minimum value is 1, the maximum value is 100. So what I've replicated that in the cube builder validation annotation. So a minimum of 1 and a maximum of 100, and optional. So these should only kick in, if they're specified. I've also explicitly put on the optional annotation as well, which cube builder understands, and descriptions as well, because those descriptions are made available as well by the CRD. So now we have this. I put that in a completely wrong folder, haven't I? Sorry about that. Let's save. Right, let's try that again. Let's put it actually in the types this time. So what's that complain about? Yeah, this is a problem. Right. Cool. Right. So that's better. Sorry about that. So now we can actually use this in the AWS managed machine pool definition. So that is, we can go to that type there, and we can make a reference to it in the spec. So I am going to go to the bottom of the spec here and add a new field, and I'm going to use the same type of annotations to denote it that this is optional, and also the JSON tags. So that is our API type updated. So because this is a change to the API type, there's certain things you have to do to make that available, i.e. within the config folder and the CRD definition. So we have a makefile target for that. So whenever you make a change to the APIs, whatever folder that is in, whether it's an experimental or the top level API, sorry, you need to run make generate. So this will go through, and we'll see it does a whole bunch of code generation. So it adds the deep copy functions, and this is using the tools from controller runtime. It will generate the CRD definitions, etc. So, but it does take some time, so we'll leave that going in the background. So within this folder as well, we have the webhook definitions. So these are mutating and validating webhooks. So this update config, we have two options. We can specify a max unavailable, as in an actual number of hosts, of nodes, sorry, that would be unavailable, or we can specify a percentage. So really, we don't want to allow specifying both of those because it doesn't make sense. So we would want to put some validation in that when someone did kubectl apply, that we check to make sure that they didn't supply both those values. And this is where, you know, some of the webhooks can come into this. So there's various methods in here. So this is, we have defaulting webhooks, which I guess you could call mutating webhooks. And we have validating webhooks as well that will just do pure validation. So what I want to do is I want to ensure that we don't supply both values for the max unavailable, but also if I do supply the update config, I want to make sure that we do supply at least one of those values. So what I'm going to do, the general, sorry, I've got a bad cough. So the general pattern here is we have like a validate function that will validate a specific field or struct, and then that is then called by the top level validate or create. So what I've done here is I've created a new function that will validate that node group update config. So this follows the general queue builder pattern and using the API types for returning field errors. So it's a fairly standard pattern. So really what I'm going to do is, you know, if we do have an update config here, I'm going to do one test to see, you know, if both of the max unavailable and unavailable percentages are nil, and then return an error to say, well, actually, you need to specify one of these if you are specifying the update config. And likewise, if you specify both of them, then I don't want to allow you to apply that kube config. Sorry, that config anyway. So so I now need to call this. So there are top level functions that will on the webhooks that will get called depending on whether you are creating or applying those manifests. So you can see we have a validate create here. So what I would essentially do is copy this, essentially this pattern, and this will call all of the sub functions to do all of the various validations, and then it aggregates all of the errors within that that manifest or against that API type, which is the managed machine pool here. So change that to validate node group. So this will now do the validation when we do kubectl apply, and it's creating those AWS managed machine pool for the first time. So we also want to do the same sort of test when we do an update, because there could be a scenario where you have a node group and then you want to later set the update strategy. So there is, funny enough, a validate update method. So we're just going to put in exactly the same function call in there. So that's our webhook. So we shouldn't allow now a user to make any changes that are not allowed according to this. So there is something else that we would ideally do here. There is some unit tests for the webhook that go in there, and we you know, in an ideal world we would add some tests in here to make sure that we did, you know, that functionality on the validation was tested. So I will put an example in here. So this is validate update, validate create. So what you'll see is we often use the pattern where we have test cases. So we have one top level test function, and then we create a number of test cases within that, and then run sub tests. So in this instance, we got a top level function to validate that creation webhook, and then you'll see this this struct, essentially anonymous struct, anonymous slice of structs with all the test cases. So I've just added one that says basically, I've just done the update, haven't I? Never mind. We would put some unit tests in there like that. Yeah, okay, that should work. So I've put you two test cases in here. So if we have a valid config, we just got one of them specified, it should pass. And it should fail if we supply the update config, but no actual max unavailable. So we have these you know, I'm expecting an error. So I can quickly run that if I want from in here, just to make sure. So I would do the same for the update as well. So now we can sort of ensure that we are getting the data in from the API in our API definition in the correct format. So now we need to actually do the reconciliation. So we have a controller that will reconcile the AWS managed machine pool. So that is also in the experimental folder under controllers. And then you'll see one called AWS managed machine pool controller, funnily enough. So this is the common queue builder pattern. So we follow, I guess it's convention, I guess, across most of the providers in how the reconcile method is implemented. So we do a whole bunch of stuff at the top level, like getting the AWS managed machine pool and getting the cluster from API server, and anything else that is required to do the reconciliation from a Kubernetes point of view. So what you'll see here is we get the AWS managed machine pool that is going to be reconciled. We do some other stuff. So we get the owning machine pool. So if you remember from the previous session, a CAPI machine pool owns a Kappa infrastructure implementation, which is our AWS managed machine pool. So we get both of those, and we do some other stuff. We check if reconciliation is paused, etc., etc. But then we come down to this point here, is where Selev mentions we have this concept of scopes. So we get all of that data, and then we create a scope, and that's, I guess, the scope of this reconciliation. So that holds all of the data that we need to do this reconcile, and this is a common pattern. And then right towards the bottom, you'll see just a little test to say, well, actually, is this a create stroke update reconcile, or is this a delete reconcile? And that follows this pattern where we just look at the deletion timestamp. So for us, we were interested in the create an update. So we're going to look into reconcile normal. I'm just checking at the time. And this is where you'll then see the second part that Sadef mentioned is within that reconcile normal. So the create an update, we're going to make use of a service to do the actual work. And you can see here that we are going to create an instance of the node group service, and we pass in that scope. So that service then has everything it needs really to be able to reconcile that node group. And then we have this, then we call a function on that service. So reconcile pool. So if I go back to the packages folder and then to the cloud and then services and then EKS, because I know this is in the EKS package, you can see there. So you will see node group. So we've tried to split it up like this, so there is individual services that do a particular task, and for this one, it is the node group. Sorry. Normally within the service, you will see a number of sort of standard methods. So to query, do I have this type of resource in AWS? So do I have a node group? And then depending on that, you might then call a create node group or delete or update node group. So that generally you have those type of functions within every service. And if you look at the top, there'll be the reconcile pool. If I go at the top, sorry. Right. Fine. Reconcile. It's all going wrong. What's going on here? I know. It will be there somewhere. I'm obviously, I've got fat fingers today. But essentially we need to use this update config in two places. So we need to do it when we create the node group and when we update the node group. So there is, so if I go back to here, so we have this function called create node group in the service. So if I'm going to create a helper function in here, just for the sake of showing how to do this. So I want to generate a SDK, AWS Go SDK struct, which is this one here. no group config is the one we saw in the documentation, and I need to generate that from our representation of it. So I've just created this function here, update config. So I'm going to use the scope here. So you can see the scope within this service to get the update config from the managed machine pool, and then I'm going to convert that to the SDK type. So we do have a separate package for conversion functions. It's not generally used everywhere. But there is if you look in the same package cloud converters, we do have, especially on the EKS side, we do have functions that will convert from our types to the AWS types. So for me, I would also add one in for this, which would be, this is very Blue Peter. So I would have a no group update config to the SDK, and from the SDK. So it's just conversion functions. It doesn't do much. So I now have that. So this satisfies this update config. So what I can then do is actually then start to use this when I do the creates. So if I go to create no group, so I need to update config. So we can see we've got the update config here on the AWS SDK call. So what I should be able to do then is just get that, what did I call it? Update config, funny enough. So I should be able to do that. Sorry, go. So this is, I would do more. I'd have to do the update as well, but we will. I won't cover that now because we're going to run out of time. So I've made a change. So there's a couple of things I would want to do at this point. First one is to run the tests. So these are the unit and the integration tests, not the end-to-end tests, because they take a long time. So there is a make file target for that. So it's just make test. So I would run that, and hopefully this would run all the tests, make sure that nothing's broken, and it would also run that additional test that we added to the webhooks for this functionality. So that should hopefully pass. Yeah, let's keep that going. I got failure. So I'd have to go back and fix that failure. So the second thing I would do before submitting a PR is also run the linter as well. So we also have a target for that, which is make lint. So this is just going to use Golang CI lint, and this will go through as well. So the reason why we want to run these locally first is because we run these as prow or CI jobs via prow on the pull request. So this will block a pull request if these are failing. So you can see here that I forgot a full stop on one of my comments. So if I'd actually done the PR here, prow would have failed this, and you would have seen on the PR, which we could actually go and do now. Potentially.
Yeah, I also usually run the make verify when there's especially an API change. It's a good practice.
That's a good shout. So I did notice earlier that my generate is not working for some reason fully. So I created a temp version of this. So I need to look at that. So that, you'll see that this is now updated the CRD with our change. So what I would do from here, I know we're going to run out of the hour. So from here, assuming that my linting was passing, the tests were passing, and as Sadef says, the verification was passing, we'd then just do a normal commit, create PR from that point onwards. For this change, I would also update the end-to-end tests for EKS so that we are also exercising that part of the config change that we've done to make sure that works. But I think we will cover end-to-end tests specifically in a follow-up session. So I'm going to pause it there, I think, and see if there's any questions on what we've just done there.
Are you typically, when you're writing these, are you typically writing all of it end-to-end tests simultaneously with these feature ads?
Historically, no. So, we haven't been so good with the end-to-end tests, especially on the EKS side historically. So we would get the feature in with just unit tests, and then potentially retrofit them. But in an ideal world, we would, and for this, I would do them as one. So I would do the change and also include updating the end-to-end tests.
Yeah, especially if it's a big feature, yeah, we would prefer to merge end-to-end tests together with the change itself.
Yeah, we haven't been as good as we should have been historically on this front, and the actual end-to-end tests on the EKS side really need expanding.
What's in the verify make target that's not caught by the end-to-end test?
So there's all sorts of things in there. So it will test, for example, let's go into one of these files. So if I just go into this EKS file here, so one of the tests that verify will do is it will check that we've got the copyright file, for instance, and it's got the correct year. It will also test, it will also do like a go mod test as well. Make sure your module file is up to date. And so if it does some other stuff as well, doesn't it?
Yeah, also it checks the generated CRDs are up to date after an API change.
Yeah. So so if you're interested in those, a lot of the stuff is, it does invoke like a shell script that actually is within the hack folder. So you can see verified boilerplate, which will check the header and stuff like that. But yeah, there are. Let's go to the make file. Yeah, so you see down here. So I could just run that myself now. Make verified boilerplate? Yeah. Of course. Yeah, and that has that done anything? I don't know. It's hard to say. I guess one thing we also should mention is a lot of the tools that we use in this make file. We use specific versions of things like Golang, CI lint, and whatever other tools we might use as part of the make file targets. And what you'll see is we've adopted the pattern. You'll see quite through a lot of CAPI is within the hack folder. There's a tools folder, and then within there we have a separate package essentially. So within the Go mod, we specify specific versions of whatever tools we need. And then we have a tools Go file that we also import, and then within our make file, we actually compile those specific versions, and then we use those. So yeah, if you're wondering where those come from, they're all within the hack tools folder.
Got it. Thank you.
Cool. I guess are there any more questions? Would anyone be interested in like what would they like? I guess Josh and Clifford, any specific topics for any follow-up sessions?
I think you just mentioned the end-to-end testing. That would be super helpful, I think. Yeah.
Okay. Yeah, we can definitely do that. I guess things with end-to-end tests, it sucks a lot of your life away. They take forever.
Yeah, I was just thinking that might actually take a long time to just do a presentation on it because of that, right?
Yeah, but it's definitely valuable because they do provide a lot of safety for us.
So Josh recently started writing end-to-end tests. How was your experience, Josh, understanding the code?
It was very iterative. It certainly is a process. I'm trying to. I noticed that even though we use the same end-to-end test framework, there's not a lot of continuity across providers in terms of the framework of those tests. I think that would probably make things a bit easier, but other than that, once you get it, it's fine. Is there a feature or proposal process for the provider, like once something gets to be a certain size? Or
Yeah, so it's not very prescriptive. So we have a couple of ways. So yeah, things that are obviously fairly big changes or impactful or risky. We follow the proposal process. So we do basically the same as upstream CAPI and Kubernetes. We have a proposal doc, and then we go through that process of reviewing it. And then for smaller changes, we also have ADRs as well. So if we've made a decision that is, it's not big enough for a proposal, but we do want to capture why we did something, then we have ADRs in the repo as well. And actually for that proposals, we follow the approach where you have like a Google Doc that has the same headings or HackMD to start with, because it's easier to get initial feedback that can be quite a lot, and then later on we then migrate that into Markdown within the repo for final, I guess, approval.
Thanks. It's helpful.
Cool. Well, should we call it a day there? Then we will arrange the follow-up end-to-end test session, and also if you're interested in any other sessions, we have a discussion, GitHub discussion where we can track proposals for other sessions.
That was helpful. Thank you. I appreciate it.
Good. Thank you, both of you. This was great.
Cool. See ya.
Thank you.
Bye.
Bye.